Testing, testing. Aha. Now we appear to be working. Okay, so now I need to share this. Okay, so thanks, Paul. It should be working now. Is that right? Just let me know. I can see a little green dot. Wonderful. I don't know why I have these problems with live streaming. I want to be able to simulcast both YouTube and Twitter, and I've got software to do this, but for the life of me, it never seems to work. It's 50% of the time the YouTube alone works, as we just saw. Everything at my end was working, but YouTube just wasn't picking up the audio. I don't know why. But now we are fixed. Now I have so many questions, I'm just going to dive straight into them in no particular order. And as I always say during these live streams, forgive the fact I have a number of beverages that I will be drinking throughout this to keep myself hydrated. So everything from water through to Coke and a protein shake as well. So that's going to be happening as well. My screen in the back will periodically go on and then off again. I don't know why that happens either. So all sorts of technical problems, but that aside, you don't need to know how the cookie is made or the sausage is made. Let's just dive straight in. Thibault asks, it's rare that advice works, but still I'll ask for advice. How did you become so good at communication? What's your advice? In particular, oral communication. For example, on air chat, you seemingly can explain anything off the cuff with great eloquence. Well, thank you, Thibault, for the compliment. I don't know how true that is. All I can say is I recall as a student, and I don't blame school for this, by the way. I think everyone kind of grows up this way. I didn't like speaking in front of groups of people. And simply because I didn't like speaking in front of groups of people, I coerced myself into doing it. I thought, I want to do that thing that I saw other people doing. I saw my teachers and admired the fact they were eloquent. I saw popularizers of science that I admired, and I thought, I want to do that. I want to be able to speak off the cuff without ums and ahs, without too many pauses, and as you say, have a certain degree of eloquence in doing so. I wanted to know what I was talking about. That was one thing. And then I wanted to be able to explain the thing that I had knowledge of in a way that didn't make me scared. Jerry Seinfeld has that great line in his stand-up routine that of all people's fears, when you survey them, death is number 2. So what's number 1? The number 1 greatest fear that people have is public speaking. So at a funeral, most people would prefer to be in the casket than delivering the eulogy. Now, I don't know whether that's true or not, of course, but I knew that I felt within me a fear of speaking publicly. And so in the same way that, some people have a fear of water, you just got to dive in. And so I started doing that. Every opportunity I had at school to speak in front of a group of people, I would take it. And it was very uncomfortable for a long time. And then I got over it. And then I became more proficient. I actually became a science communicator at university because that's really what I wanted to do. There's this fellow in Australia, his name is Dr. Karl Kruszelnicki, or Kruszelensky. And I think he has a Polish background, but he's an Aussie and he's often on the radio. And he was just someone that I grew up with. He's still around. He's on Twitter, and he would just answer random questions from people. And I really admired this guy. He had all these degrees. That was the first thing. He seemed to know about everything from medicine through to how to fix a car. And indeed, he was a car mechanic and a taxi driver, and he was a medical doctor, and he was a scientist. He did degrees in physics. And so he had all this knowledge there. And so he'd go on the radio and just answer people's random questions. And I thought, that's so cool. I wish I could do that. And so not only did I start learning the content, so to speak, I was just interested in everything, but I took every opportunity to talk about this stuff as well. And so when I went to university, and not only were there courses in science communication, they were rubbish, never mind that. I took like one subject and it was a complete waste of time. But there was actually a job you could do. You could work for this place, now defunct, at the University of New South Wales, where I was, called the Outreach Centre for Sciences. And they were paying students to be science communicators. I thought, this is it. This is my ideal job. And up until that point, in order to pay my way through university, as I've told the story often, I was a security guard. I was a mall cop, and that's what I did. I'd go to university, lectures, tutorials, and labs. And then when I finished that, I'd go off to a shopping center, huge shopping center, still exists, big shopping mall. And I'd do laps of this shopping center and get paid to, arrest criminals, patrol, do all the usual things that a mall cop would do. But it was hard work. It was stressful. No one ever calls the mall cop because they want to tell you, I've got this lovely person in my shop. I'd like you to come and meet them. No, it's always the worst possible situation that day for that shopkeeper or for the people, the customers, and you have to come and solve the problem. So although it was fun and exciting, sometimes it was terribly boring and other times, and I was able to mix in my studies with that job because there would be long stretches, especially at night, where there'd be very little to do. And I'd carry around my notebook, ostensibly for making notes, but it would be filled with my university study, my physics formulae, my mathematics, chemistry, all that stuff, philosophy. And I'd be wandering around the shopping center at night, doing my job, looking around, but, now and again, reading the notes. So that's how I'd memorize and commit to memory a lot of this stuff. But when the job was advertised at university for to be a science communicator with the Outreach Centre for Science, I thought, this is amazing. And I was desperate to get this job. And I went for an interview, and they gave us an article. I can't remember what the article was. Something about how the eye works. And you had to explain it to this panel of people. And, it was sort of 10 minutes before we went into the interview. They said, here's this article, read this article. I want you to come in and present it to us. I thought, that's a good test. That's a good test. Can I absorb what's here in this article and then represent it to people? And I did it. I thought I did pretty well. Long story short, they gave me the job. And it was a fantastic job. We'd travel around to schools promoting the university, and I'd do chemistry shows. So I got to learn how to use liquid nitrogen. The remarkable thing with the liquid nitrogen, I did all the classic stuff that you do with liquid nitrogen, the most spectacular of which was you'd put a small amount of liquid nitrogen into a sort of 2 liter or 1.25 liter soft drink bottle, big plastic thing, just a small amount into an empty one. And then you'd put it into a large garbage bin of some sort. And the liquid nitrogen would, of course, vaporize. It'd take some time to do so. But in doing so, it would also make the plastic out of which the bottle was made frozen solid, crystalline. And the pressure would build from this small amount of nitrogen, increasing its volume by, a factor of 1800 or something, whatever it is, going from liquid to the gaseous phase. And the bottle would blow up spectacularly. I mean, the explosion was massive, possibly a little bit dangerous. And that's why you'd put it into this bin, and the bin would contain the explosion, but it would blow the lid off the top of the bin, and hugely noisy. And this would usually be the capstone on the rest of the show. And what always surprised me about that was the fact that we had to go through all this training and safety procedures and had to be very careful in handling this stuff. Quite right, too, because you get any on you and it could, freeze dry your skin. And if you put it in the wrong spot, it's going to vaporize and cause an explosion, all this sort of stuff. Things can go wrong with liquid nitrogen. It's a dangerous substance. It can be a dangerous substance if mishandled. And yet, on television, you would regularly see these TV chefs and so on in the modern day be making ice cream out of the liquid nitrogen. And in fact, I can walk around, Sydney and find these ice cream places where they're just pouring the liquid nitrogen around like no one's business. No one seems to care. Some people don't even have gloves. And it's like, why was I forced to go through all this safety training, as a science person when the chefs over there don't seem to care? Different rules. So anyway, I got to do these chemistry shows. We got to do electricity shows. We'd make, again, with the 2-liter bottles of like Coke, you'd turn these things into capacitors by putting aluminium foil on the outside, and then you'd create these big sparks. That was a dangerous show. We'd do that one. We'd do all sorts of chemistry shows. But as fun as that stuff was, we'd do oscillation reactions. That was really cool, where the chemicals would move between this bright pink color and a transparent color, bright pink, transparent, bright pink, transparent, as the solution went from acidic back to neutral, and the color change was due to the indicator indicating, now it's acidic and now it's not, now it's acidic, now it's not. Now, why does that happen? Because it's an equilibrium reaction. I won't go into the chemistry of oscillation reactions right now. I could probably barely remember it myself. There was the clock reaction. The clock reaction is fantastic. Iodine clock reaction. Look that one up on YouTube. We would do that, and you'd have like 4 different beakers of different concentrations of this stuff, where you'd have iodine, and the iodine would there be with starch and various things in different concentrations, and you mix it together, and then after a certain time, like 30 seconds, the thing would go from perfectly transparent to perfectly black. I mean, black like the Coca-Cola here, and just like that. Look it up on YouTube. Fantastically spectacular kind of reaction if you've never seen it before. And because they'd be at different concentrations, this one would take 30 seconds and then it would go. And then once you got practiced at this, you'd go, all right, as if you're doing a magic trick, because you'd know after exactly 30 more seconds, after 1 minute, the thing would go bang. And you could change, you could alter the concentration so that, you'd wait 30 seconds, it'd go bang, black, and the next one, 35, bang, bang, bang. And, you'd be pointing at these things and they'd be changing color as if, by magic. So that was fun to be able to do that and to be able to explain what was going on. Mixing cobalt chloride with water, you get a certain color. Cobalt chloride and alcohol gives you a different color. And I took all of this stuff, of course, and then went off and became a science teacher where I could use that and be kind of an entertainer. I enjoyed being up on stage, doing that kind of thing and explaining that kind of thing. And so simply because I became practiced at it as a science communicator at university, I realized this is what I like doing. I love doing this. I just love talking to people about this. I loved having people ask me questions, the curiosity line up in people's eyes, and then the fascination as you begin to explain it to them, especially the kids, of course. We would be associated, my team, for want of another word, at the Outreach Centre for Sciences, part of the science faculty at New South Wales University, would be associated with the School of Optometry. That was also part of the science faculty. And kids from various schools would come in to get free eye checks. And before they went in to see the student optometrists, we would have them as 5 and 6 and 7 and 8-year-olds, and they'd sit there and I would explain the basics of the anatomy of the eye to them and how the eyes work. And that would be so much fun. I realized I love doing this. I love talking to kids. I love talking to people of all ages about especially science, and then showing them stuff and entertaining them. I knew I was never going to be an actor. I knew I was never going to be a stand-up comedian. I knew I was never going to be a politician, but I still wanted to do that thing, be in front of people and just talk to people about not just anything, but science in particular. And so it was a seamless transition from science communicator at university, which is kind of a prestigious role, to science teacher, far less prestigious, but still enjoying it. Because as a science teacher, of course, you've got the same group of students. It's a much, much, much harder job, I have to say, is a science teacher than science communicator. Because, and I apologize to the stand-up comedy community, and entertainers of all sorts, because as a science communicator, you kind of are. It's easier than being a teacher because as a science communicator and all those other entertainers, you're doing the same thing day after day after day. It's the same show. And so as a science communicator, we would travel around from school to school to school, doing exactly the same lesson, exactly the same spectacular show with liquid nitrogen and oscillation reactions and clock reactions and electricity and all this fun stuff. And all the kids would be excited. And it's like, why can't our teachers be like this? You're so much fun. And these experiments are so exciting. And you're so clear at explaining all this stuff. And it's like, I just do the same lesson day after day after day, traveling around to different schools. And of course it's impressive because I'm so practiced at this one lesson. And everything works because it's so well rehearsed. And I've got a different audience every single day. The poor teachers have the same audience day after day after day. They don't get to rehearse things quite so well until you've been in the job for like 10, 15 years, which I ended up being. And then, after 15 iterations of the same kind of thing, and perhaps there were sometimes, especially in mathematics, you'd be teaching fractions 5 times in a row from year 7 through to year 12. And so you get practiced at that. But as a new teacher, it can be extremely difficult. Not only the classroom management stuff, but just trying to be entertaining. You come in full of enthusiasm that you're going to be like the science communicator, which is what I was at university, thinking, I'm just going to inspire all these kids. It's going to be fun every single day. No, it is very hard to be entertaining every single day, even if the material is changing every single day. Because sometimes you've got to think, well, if you're a good teacher, you've got to be across the stuff. In terms of physics and chemistry and geology, of course, I knew all that. I knew basics of biology, but then you'd get into niche areas of science sometimes that I might not have covered. And you think, I've got to teach this today. I'm not exactly sure. It was rare that happened, okay, because I was always a science nerd. So I was always just fascinated by science. But now and again, something would come up where you'd think, ooh, better bone up on this, better read this a little bit more carefully. And the kids would ask questions. And of course, I was one of these people who was quite happy to say, I don't know the answer to that. There are some teachers who are terrified of ever admitting ignorance. But I didn't mind. Anyway, my point here is, without going off on a rant, that it's much harder to be a teacher and entertaining and funny and have spectacular demonstrations as compared to the science communicator. Although ostensibly you're doing kind of the same thing, the science communicator is doing the same lesson day after day after day, very practiced at that. They can be entertaining at that. It's like doing stand-up comedy where you're just doing the same routine all the time, and you can easily riff off the audience, okay, because that's the rare exception to the rule. You're sticking to your material otherwise, the same as I suppose a musician does. You just become very practiced at the same routine, or an actor, you're becoming very practiced in the theater, all that kind of stuff. A teacher has a uniquely difficult role because you have an audience there, and it's the same audience, the same students day after day after day, that you are supposed to be entertaining and educating. And you've got different material every single day as well. It's not the same material that you've practiced and rehearsed unless you've been in the job for a long time. This is why teaching is so hard. And so I know I give a lot of shtick and I'm hard on the education system, and some teachers are cruel and nasty, but overall the job is very difficult. I can only compare it to being a police officer, like that level of kind of difficulty. It's different in terms of difficulty, but it's that kind of thing where you have to continue to maintain the happy, pleasant demeanor A lot of police don't do that, of course. They're exactly the opposite. They come across mean, but they should be. Ideally, they should be. Same as teachers. They should be coming across with a happy and pleasant demeanor. You're dealing with different people all the time, and no matter how often you've encountered this same situation, you have to somehow find it within yourself to treat this moment as unique and not something that you've always dealt with many times before. Which is why it is uniquely difficult, I would say, teaching and police. And I've had some kind of dealings with both. Okay. So that's how I became, and these are Thibault's words, so good at communication and explaining anything off the cuff with great eloquence. I don't know that I agree with great eloquence. I've seen people who are truly great orators. You look at someone like Douglas Murray. Okay, fair enough, he's not talking about science, but I mean, that man under stress has unflappable eloquence. Oh, I guess that's the other thing. I loved debating at school, and I became proficient at that, especially at university as well. I loved getting into public debates like Douglas Murray, so long as it was within my wheelhouse. I didn't like the artificial debates that you would have at school debating, where it would be this topic that you weren't really interested in, and you'd have to take a side that you didn't fully endorse. So that was, but that would still allow you to practice. It's all about practice. It's like everything else in the universe, Thibault. You know, you want to be able to explain things better. You've just got to get out there and do the thing. There's no point watching someone else swimming, doing gymnastics, doing physics, or communicating. You have to do it yourself. And then once you've done it yourself for a while, you realize where the hazards are and all that kind of thing. Okay. I'm just taking a break with a drink for a moment. Now, Thibault's asked another question. That's taken me, 22 minutes to get through one question. So let me move a little faster from here on in. We'll stick with Thibault. He said, yes, asked, can you explain again why morality is objective? I've already listened to Topcast episode 109. I understand knowledge in morality helps solve or not moral problems. But can't those problems be subjective? If so, wouldn't that make morality subjective or not? P.S. I actually don't think morality is subjective, but the explanation has not clicked for me yet. Okay, so my view on this is that objectivity just means that there's a truth of the matter out there in the universe in some sense. The laws of physics are objective in that it's not a mere matter of opinion what the laws of physics are, or even what our knowledge of the laws of physics are. It's possible to be wrong. That's the fallibilist stance. And the fallibilist stance is only possible given the objectivity of reality. It's not a mere matter of opinion. That's subjective. And subjective also is about how, well, as someone has responded here, and as I often make this point as well, following Sam Harris, following other philosophers, there's two senses of this word, subjective and objective, the distinction here. There's ontologically objective and subjective. The ontological version is that there are objects out there in the world beyond your mind, whereas you are a subject experiencing stuff. There's the objects and then there's the subject. So objective is stuff beyond your mind. Subjective is stuff within your mind. That's the difference. You are a subject. What you feel and experience is the question of qualia and consciousness. What you experience is subjectivity. Then there is the epistemological stance where you say objective means it is actually true out there in the world and not a mere matter of opinion. The subjective sense there is mere matter of opinion. It's just your taste. The two are related. So why is morality objective? What I say, increasingly on this point, is that there are better and worse decisions to make in order that we correct errors faster, in order to make progress better, in order to not slow the growth of knowledge or cause a regression in our knowledge. As David Deutsch says, if there's going to be any fundamental moral claim, it is do not destroy the means of error correction. So if you're heading in a direction where you are slowing down the means of error correction or eliminating the means of error correction, preventing errors from being corrected, that's objectively bad because it's going to slow progress, which is bad because that's going to harm people. So it can come back to harm, it can come back to suffering, but those things are emergent consequences of the deeper truth, which is an epistemological one about the correction of errors. Morality, in truth, is about epistemology, the creation of knowledge. How we as individuals and as a society can make progress and improve objectively our circumstance to make better widgets, technology, progress in science, reduce suffering. Okay, these things are all elements of, but none of them are foundational in the same way that correcting errors is foundational to allow for all those other things to happen. So if you are destroying the means of error correction, that's bad. And as a consequence, that can slow down technological progress, scientific progress, and it can cause suffering. But whether it causes suffering or not is just a consequence of this deeper truth about error correction. And error correction is, of course, part of epistemology. And as we are beginning to realize, epistemology, the possibility of creating knowledge, the possibility of correcting errors is part of physics. So morality comes out of physics. Now, of course, people hate this, but I'm not a reductionist. I'm not saying there has to be a deterministic way to figure out what we should do in any moment. You can't look at the laws of physics and that will tell you what to do. I'm saying the laws of physics can constrain what knowledge can be made. It just puts limits on things, but it doesn't tell you, it tells you what's possible, but not what you should make actual in the moral realm. That's the way in which physics and morality are linked. If you want to say, all of epistemology somehow reduces to physics and all of morality somehow reduces to epistemology, fine, but it doesn't ever tell you, none of those logical moves ever tell you that there therefore is going to be some way of referring to the laws of physics to tell you what you should do next. And that's the question, the central question of morality. What should I do now? What should I do next? You've got this range of possibilities. What is the case at any moment is the domain of science. What are the laws of physics? What happened yesterday? What is going on right now? These are science questions. You might say, well, what is going on right now? That's journalism. What happened yesterday? That's kind of history in some sense. What are the laws of physics and biology and chemistry? That is science. But all of these things are matters of the physical sciences, really. It's a matter of objectively what's going on, which is separate to morality of all the things that could now happen, that the transformations that we could undertake using our wealth and our knowledge and our resources. Which one should we pursue? That's morality. And there are better and worse moves to make there. There are better and worse decisions to make within that space. That's why it's objective. And what is the criteria for better and worse? That's a whole other question, and we could do an entire podcast on that. I would say the things that allow for the fastest progress to make things better. We want people to stop dying. We want people to stop suffering. And we don't want to have to wait 1,000 more years for immortality. We want it tomorrow. We want to cure diseases, cancer and viruses tomorrow. So speed makes a difference. And anyone arguing for authoritarianism to slow things down, arguing for anti-democratic institutions, all that kind of stuff, are doing a great disservice to the world, humanity, civilization, and morality. There are objectively worse moves to make. So that's why, Thibault, morality is objective. Can problems be subjective? Yes. Okay, in the sense that all problems are subjective. They are parochial, as Popper and Deutsch say. In other words, you have problems. It's not like there is a single problem for everyone for all time. That would be a universal problem. You can have universal solutions. You got this problem of why do koalas look the way they do? That's a parochial problem. But the solution, because of evolution by natural selection, is a universal truth about how life evolves and diversifies. So although the problems are parochial and subjective, the solutions may not be. Sometimes the solutions will be. What do you want for dinner? It's a subjective problem with a subjective parochial solution as well. You want to have Indian food or Chinese food or just a sandwich, whatever. That's just for you. That's not a universal solution. But in science, you can get universal solutions. Okay. Hopefully that helps, Thibault. Peter Stromberg, aka Pez, Papa Pez, at Papa Pez on Twitter, has asked, if you are familiar with the Ludwig von Mises philosophy of science and praxeology in general, how do you think it relates to Popperian philosophy of science and epistemology? Are they compatible? Yes, I'm familiar with Mises and the Austrian School of Economics more broadly. I know that Mises and Rand knew each other. I don't know a lot of details because it's kind of like, to me, economics is kind of like chemistry in that it's cool, it's true, it helps, it solves a whole bunch of problems. Once you understand the basics, which I think is most important, then you get how it can't possibly conflict with physics and epistemology. There are no contradictions in reality. And in our deep explanations, insofar as there are contradictions, they can be resolved. There aren't that many contradictions between organic chemistry, if there are any, and inorganic chemistry and fundamental physics. It wouldn't make sense to say, hey, here's this reaction in chemistry that defies the laws of physics. If that happens, you've got a problem. And you'd probably say, well, you're making a mistake when it comes to understanding what's going on with this organic chemistry reaction. The laws of physics dominate. It's not that you've just proved wrong quantum theory with your little reaction going on there in the beaker. There's something wrong with what's going on in the beaker. You haven't interpreted things correctly. In the same way, if your economic theory is immoral, leads to suffering, leads to, as we were talking about before, slowing the growth of knowledge, destroying the means of error correction, then your economic theory is wrong, objectively wrong. So are they compatible? Well, Mises was talking about human behavior and basically economic theories. So of course it has to be compatible with Popperian philosophy and epistemology more broadly, and science. These things have to cohere. They're just about reality, about how to make progress. But in the same way that me personally, I got to second year chemistry. I love chemistry. I was better at chemistry in high school than I was at physics. I don't know why, but I loved the mole concept when I first encountered it in 14, 15 years of age. And I thought, this is so cool. God, this is so powerful. Being able to figure out the mass of the products given the mass of the reactants, and this chemical formula would allow you to predict exactly how much hydrogen gas was going to be lost during this reaction of the acid and the metal. It was so cool. You could do these calculations and the volume of the gas that would be produced and how the temperature would change, all this stuff. So basic chemistry was just so exciting for me. I went off to university, I did more of it, and I thought, it's cool. Now we're getting into quantum theory of chemistry. And even in high school, I already had the sense that, there's this whole other thing, carbon chemistry, organic chemistry. And it was harder, but it was cool, like esterification. If you've ever done any of those reactions, could produce these beautiful aromas, like the fake smell of apple and banana and all this kind of stuff. In fact, it's not so much fake, because the reason bananas smell the way they do is due to esters, natural esters, of course. But when you distill out the particular kind of ester, ethyl butanoate, I can't remember the names of these things, but anyway, there are these esters that you can create in the lab that smell for all the world like banana or smell for all the world like apple. But they have this kind of artificial quality because you're only producing just the one chemical, whereas of course real bananas smell the way they do because of a combination of chemicals. But the reason why you can have those lollies or candies that smell like banana is because you can produce artificially this fake chemical stuff, the ester. And it's complicated. You have to do it under reflux. But I knew I liked physical chemistry. I knew I liked the inorganic stuff. Once I got into the organic stuff, like esterification, it got more complicated. And I thought you had to remember all these reactions. And then once I got to first year uni, it was getting harder, the organic especially. The inorganic I still liked because it was just clean. It wasn't 1,001 different reactions. Second year, I just gave up on organic chemistry altogether. It's just too much. It's too complicated. And it wasn't what I was interested in. It was becoming more and more emergent. For every inorganic chemical reaction, the industrial chemical processes that mining uses to create, steel and all the fun stuff that I really liked, acids and bases. For all of those, there are like 100 different organic reactions. It's so much more complicated, complex, difficult. But, that's how you make plastics. And this all comes out of carbon. This one element is just so much more rich in terms of the number of reactions. And so I admire the organic chemists and what they can do and how powerful that entire field is, how complex it is. And it leads to biochemistry, of course. That comes out of that. This is why medicine can be so difficult, because you're dealing with just this vast number of organic chemical reactions. I prefer the inorganic stuff, the hard, solid metals and acids and bases and that kind of thing. What's that got to do with this? Well, in the same way that I get bored with the organic chemistry, but I understand the value of it, I can look at it and go, this is fascinating, absolutely fascinating. But I just can't be bothered. Economics evokes the same feeling within me. I know that there can be no contradictions between organic chemistry and what I'm truly interested in, which is like physics and epistemology. I know that there can't be any contradictions between the fine details of economics and physics and epistemology. And so therefore, they have to be compatible. Mises' praxeology, Rand's understanding of economics, the fine details, Thomas Sowell's work here. Ignore all the socialist stuff and, how central banking should work and that kind of thing, that nonsense. Put that aside, okay? People drawing graphs of the effect of interest rates on things, okay? True, but anytime you have the government intervening in things, it just ruins everything. And so that seems to me to be a basic fact about economics. And then everything else just flows as a matter of logic. It's kind of like organic chemistry in that sense. It's like, oh, carbon has a valency of 4. It can make these bonds with itself and chains and loops, and it can bond with other things to make alkanes, alkenes, alkynes, and then DNA, and it just gets more complicated. But it's all just a logical consequence of this simple fact that carbon can bond with itself. And then you end up with this huge field that logically falls out of carbon chemistry. This entire thing, organic chemistry, falls out of that. But although I think it's fascinating and amazing, I personally am not so interested in it. So, yeah, that's what I think about economics and Mises. I think it's brilliant, and I admire the people who are really into this stuff. Jeroen Broek, Ayn Rand, Mises, the Austrians, but I just can't get into it. It's like medicine, right? The same sort of thing. I admire the people who do it. There can't be a contradiction at the heart of what medicine says and what physics says about reality, but I personally can't find it gripping. I just admire the people who do. So that's what I think about, this. Is Popperian philosophy and Mises praxeology, are they compatible? Absolutely. They must be. Whatever the truths are about economics and finance, they have to be compatible with the truths of physics. And insofar as there is a disagreement, well, that's just a problem and we have to resolve it. Yeah. Let's keep going. People often ask me this. Cam Peters has asked me this as well. Is there anywhere you substantially disagree with Deutsch? I would say I don't know. Not that I'm aware of. I'd love to find out if I could, but this is the reason I've fallen in love with his work, the books, his papers. It's because I can't find anything to disagree with. I wish I could, but I can't. My avoiding the answering of the question often comes down to, I know that David likes tea, and so do I. We even agree on that. Tea is the king of drinks. That said, David doesn't seem to mind tea bags. I prefer the loose leaf. So there we go. It's maybe a fundamental disagreement. If I have a choice, I'll have the loose leaf tea every time. And only under desperate circumstances, when I'm visiting the home of someone who doesn't have loose leaf tea, will I have tea bags. That could be a fundamental disagreement. Otherwise, no, I can't find anything. And when I do think that I've found a disagreement with Deutsch, like for constructor theory, what happens is that I realize myself, I better read more into this. I better try and understand what David's saying. And of course, that's the way in which I resolve things. And that often happens, right? I think, I disagree with Popper on this, or I disagree with Rand on this, but then I read more about what they're saying, and then I go, I get what they're saying now. It wasn't that I disagreed, I didn't understand. But that could also be where disagreements all come from. People not understanding one another. Okay. Let's keep going. Benjamin Frelich. You have said that pure reductionism and the resulting claim that a Laplace's demon is possible, at least in theory, are akin to invoking the supernatural. Does Everettian quantum mechanics, however, allow for such a demon by allowing him to predict probabilities of all outcomes? No. For one thing, probabilities are not fundamental in the Everettian picture. So, no, there's nothing, there's no way of being able to predict what's going to happen moment to moment. Even if you had a supercomputer that was able to analyze the motions of all particles. Now, I've made this point before. Is what Laplace's demon would require, right? You know, being able to see the trajectories of the particles and allow this one to go through the window and stopping this one. And so as you see this particle with high velocity traveling this way, then you let it go through, but this one's going slow. And so you stop it and you keep opening the window and closing the little gap or whatever it happens to be. And therefore you can separate out the high energy from the low energy just by looking at stuff. But of course, the problem is that you actually, by looking, you're actually interacting. It's the first thing. Looking is not a passive process. Looking means absorbing photons at the very least. That's a physical process. So observation is a physical process. There's that we can say. But also, there's no possible way of being able to look and see all particles that are going to be coming to bear on any given situation. As I like to say, even if you could have this supernatural oracle of some kind that would be able to detect the motion of all these particles in some region of space, there's always going to be a region of space outside of that from which the cosmic ray comes crashing into your field of view and upsetting all of your carefully detected measurements of everything inside of the bubble. You might say, but just make the bubble bigger to take into account the entirety of the universe. Okay, so then you're God. Then you are literally supernatural. You're going to be supernatural anyway for whatever region of space. So if you're able to see and detect every single particle in the entire universe and then react to it instantly, you're God. And so this is why I say Laplace's demon isn't possible. All these kind of ways of predicting the probabilities of all outcomes are equivalent to the supernatural. There's been a few questions about problems. Andrew Gleave has asked about, is the concept of a problem reducible to constructor-theoretic terms? And can they be regarded as counterfactuals? End quote. This is a great question that I might ask Chiara. I'm going to be speaking to Chiara Miletto over the coming weeks, hopefully, in particular for episode 200 of Topcast, which is approaching swiftly. I think I'm at 197 or 198 now, so not long. And I want that to be a conversation with Chiara. This will be a great question for her. My own opinion is, as I said before, problems are parochial. In other words, individuals have problems. Perhaps a large group of people have problems. Perhaps an entire civilization could have problems. But there can be no problem for everyone at all times, everywhere, unlike with solutions. So can we express a problem in constructor-theoretic terms? And can they be regarded as counterfactuals? Yeah, so I guess so. Counterfactual terms, you know, what might have been the case, what could be the case, what should be the case. All of these things are counterfactuals, ways of expressing what might possibly have occurred. The counterfactual world. This is what happens. This is what could have happened. This is what possibly might have happened, and so on. Problems are certainly well within the remit of that way of phrasing things. Yes. But this is a question for Chiara. Next question. Interesting things you should know about, as asked. That's the name of his Twitter account. How do you increase trust in a society? End quote. I would say wrong question, bad question. We don't want to increase trust in a society. I think trust is a bad metric. I don't think we should trust people in general. What we want to do is have an active explanation of why people are doing what they're doing. What we want in a society is not trust, but better ways of detecting and then correcting errors. You might say, oh, that's a horrible way to think about things. Shouldn't you trust your partner or your mother or your girlfriend or your sister and etc.? No, I don't think trust is the right word. You should have an active explanation of why your relatives, your friends love you and why you love them. And that has nothing to do with trust, but you understand why you should treat them well and why they should treat you well. You can call that trust if you like, but I prefer to regard that as having an active theory. It's not faith and trust, which are just emotions, but an objective understanding and knowledge of the other person, the knowledge of yourself. And it should work both ways. So it's not trust. Okay. Paul has asked, are you living as though you were mortal or immortal? I don't think about that. That's his question. It's not something that directs my moment-to-moment experience of the world. I live as if I'm not going to die in the next moment. I make decisions as if I'm going to be here next week, next year. Now, do you call that being immortal? Because that will always be true. I don't know. Ask me again when I'm 95. Maybe I'll still think I'm going to be here tomorrow. I'm going to be here next week. I'll still be making decisions like that. Maybe we all do that. I can't imagine what it would be like thinking I'm going to die tomorrow. Perhaps I will have that experience one day. I know a lot of people, unfortunately, are told by doctors and so on, you've got a week, you've got a month, you've got a year left. So they're living as though not only that they are mortal, but they know how much longer they've got left. So at the moment, I guess I'm somewhere in between. I'm living not exactly as if I'm immortal, but not like I know when I'm going to die either. Okay, Aniket, great supporter of mine, well worth following on Twitter. Aniket Vartak has asked, quote, you were, question mark, a science instructor, therefore want to ask, how can one incorporate Popperian epistemology to do a project about experimental design assigned to a middle schooler? I have some ideas, but would love to get your perspective. Thanks. Okay. Aniket. Now, Popperian epistemology is the possibility of being wrong, of being fallible, of correcting errors, all that kind of stuff. So, experimental design, goodness. What I would say is if you want to succeed at school, you've got to do what the teacher says. The teacher might be against Popperian epistemology. They might not understand it, all that kind of stuff. Not bigging myself up, but I would hope to have thought that when I was an instructor, as you say, at school, a science instructor, a science teacher, I had an active philosophy about how to treat students that treated them as agents, people, regular human beings. And I was fallible as they were fallible. And so I wasn't biased. I hope, whether or not they were coming at me with Wittgensteinian ideas, Marxist ideas, Popperian ideas, whatever it happened to be. Especially when it came to marking or grading work. I hope I always erred on the side of awarding grades and marks based upon not the student being correct for some definition of correct, but rather on things like passion, curiosity, and effort in order to hopefully foster within them excitement about the world and learning and all that kind of thing. That was the last thing I wanted to do, was to turn someone off learning. But so often teachers do precisely that in their feedback. So that said, you have to keep in mind who you're dealing with when it comes to teachers. Is this project going to be marked? What's your aim as a student? Presumably, if you're helping someone who's a kid, if you yourself are a kid, I don't know enough about Aniket, or you've got a child, they want to do well. And so that can mean literally asking the teacher, what do you want from me? These days, of course, you have these assessment criteria that the schools and teachers give you. It's like, here's how you get the good marks. Now, does the kid want to get good marks? Some kids don't. They don't care. That's great. Fine. That's a rare student, but you know, you do encounter this. And it's like, I'm just going to tell you, I'm just going to, I was often the kid who wanted to do well, wanted to get the marks. I didn't care about the truth of the situation. I wanted to know, what does the teacher want? And I'll do that thing. I was a good little boy from that perspective. But there are some kids out there who don't. They don't care about that. They're just going to write stuff, and I admire that. So what does this middle schooler, as you say, want to achieve? Do they want to get high marks? In which case, ask the teacher or look at the criteria. Or are they more interested in producing quality, unique work that may or may not impress the teacher? And then how do you incorporate Popperian epistemology into that? I would say with a focus on errors. A focus on errors, what the errors are. With science, experimental design, in physics and chemistry, the physical sciences, what you want is the capacity to quantify your errors. It's Deutsch says somewhere or other, words to the effect, and I said David would possibly not be happy with this, because I was, I think he doesn't like, it makes him feel icky, and I understand that impulse, if his work is brought into the classroom. But I did, I'd make exceptions sometimes. And somewhere in the beginning of Infinity, he says something to the effect of, a result quoted without uncertainty or without error is strictly meaningless. And I would write that up. When I was teaching experimental design, that's precisely the kind of thing I would teach my students. I would want them to learn, especially in physics. You can't just quote the result. You can't just say what the length of the thing is that you're measuring or the mass of the chemical is. You need to tell me what the uncertainty of the measuring device is. It's 5 centimeters long. Okay. Is that 5 plus or minus 1 centimeter, plus or minus 0.5 centimeters? Is the mass 3.2 grams, or is it 3.20 plus or minus 0.01 grams? I want to know the uncertainty. What are the error bars? That's Popperian. Tell me about the sources of error, both systematic, which is problems with the methodology that are possible, and random, which is this thing about error bars and how good your measuring instrument is. So there are all these sources of uncertainty. to the credit of schools and universities now, they do incorporate this a lot, but not always. So that would be my focus if I wanted to incorporate Popperian epistemology to some extent, to talk about all the ways in which this thing could be wrong. Okay, it's not only Popperian, but to say, I could have made a mistake here. This experimental design could be completely wrong. That could be a source of systematic error. All of this stuff about what I've measured could be a result of a mistake with the measuring instrument, my ruler, etc. That's Popperian. Here's all the errors. Yeah, so that would be what I would say. Let's keep going. Wow, how long have we been going for? An hour. Goodness. Okay, we'll see how we can go, and maybe I can do another one tomorrow or the next day. So I feel like I'm not going to get through everything. I'll move more quickly. Benjamin has asked, hi, Brett, can you explain how Einstein's block universe is still compatible with the emergent property of human free will and creativity? If humans can change the future, how is that compatible with the block universe? Thanks, end quote. Good question, Benjamin. So I endorse the concept of free will. I think it's just another way of talking about the reality of choice. There's nothing supernatural about free will. It's about the creation of knowledge. It's another way of expressing this weird mystery that is, what the heck are people doing? Why is it that stuff appears to arise in the universe? There's television that's in the background. How is that part of the laws of physics? Well, explanations are required in terms of physics and chemistry and science in order for people to come up with the design of something like that in a similar way, but not exactly, an analogous way to how the heck did cats arise or bugs or trees, whatever your life form is. Oh, that's evolution by natural selection. Are koalas and kangaroos somehow embedded in the laws of physics, the Big Bang? I guess, but you can't predict, given the laws of physics, that this is what will arise. After all, the laws of physics allow for everything that's possible to arise, and they do somewhere in the universe. The block universe idea is that everything is predetermined, just arising from the laws of physics, that you could somehow take everything that exists in physical reality from the moment of the Big Bang through to the end of time, and if you have a God's eye view, you just see it all laid out there. Whatever it brings into this picture is that all the physically possible possibilities are there represented in space in some way, shape, or form. What I would say Deutsch adds to this, on top of that, one of the great advances of David Deutsch is that information flow, knowledge creation, is the thing that leads to the biggest structures in the multiverse. In other words, if you had this God's eye view and you're looking down on this block universe, you don't just see all the possibilities there, like every possibility exists in equal measure, but rather some things happen more often. Those things that especially are caused by explanatory knowledge. Huge structures, when you look as God down on the multiverse, you would see things like, aha, satellites are a thing. All these civilizations have figured out artificial satellites and they're using them. And that appears again and again and again across the multiverse. Or boats, or aircraft, technology, medicine, all these things just keep on appearing in the multiverse. This information with causal power, this thing that is causing its own replication again and again, explanatory knowledge. None of it is predictable at the Big Bang because it's all happening and you can't tell what thing is going to happen more often than this other thing, what thing is going to get copied and be more useful, because that depends upon choices and preferences of people. Yes, somehow it's there at the beginning of time, but none of it can be predicted because so much of it is created. It's compatible, as Benjamin has said here, with the emergent properties of free will, Einstein's block universe, and creativity, because it must be. It must be. These things cannot contradict. You can have, it must be possible for deterministic laws of physics to be compatible with creativity because they both exist. That's it. The laws of physics determine what's going to happen. What's going to happen next? Well, it's determined by the laws of physics. Does that mean you can predict what's going to happen next? No, because determined does not mean predictable. They're separate things. Determined can mean in 50% of the universe, X happens, and 50% of the universes, not X happens. But you can't tell right now which of those universes you're going to be in, because it could be due to a quantum fluctuation on the one hand, or people's choices on the other. And you can't know now which one you're going to be in a moment from now. So yeah, that's why, Benjamin. Vish, at Falling into Film, has asked, there is hardware/software universality. What are some interesting outcomes of having one but not the other? Well, you could have hardware universality without software universality, but it's not possible to have software universality without hardware universality. Because after all, if you've only got software universality, on what is it running if you don't have hardware universality? A special purpose computer? No computer? If it's a special purpose computer that isn't universal, how can it possibly allow for an infinite or universal repertoire of software outcomes? Well, it can't. So the precondition for software universality is first have hardware universality. Can you have hardware universality without the software? Yes, sure, of course. That's the overwhelming majority of computers that we know of don't have software universality. We do. We, people, have this software universality. In other words, we can emulate the behavior of any other bit of software. We can do what any other bit of software does, what any other physical system does by choosing. And we can do that thing to arbitrary accuracy, but not perfect accuracy. In particular, we will decide to do something else after a while. So we're not, although we're universal explainers, we can't be universal constructors. Universal constructor, among other things, is hardware anyway. Let's not get into that. The point is that your capacity to explain anything that's out there depends upon the hardware that you're running on, having also this capacity to do anything. But the hardware that can do anything may not do anything because it might not be programmed to do just anything. It might be programmed to do a specific thing, which is what the majority of computers are like. They do one thing. They do one thing exceedingly well, even though they could do a whole bunch of other things. I will be back in, let's call it 2 minutes while I go and get myself some water. Bear with me. Apologies. Oh, I've returned. Okay, where are we up to? Universality. Okay, so we've done that. Let's keep on going. Braden Jenkins has asked, from where did you derive your optimistic view on the nuclear defensive capabilities of the US? It seems to contradict the mainstream consensus. End quote. I didn't derive it. That's the first thing. I never derive anything. I guessed it, given what I would regard as good explanations about Enlightenment traditions, technology, the work of Popper and Deutsch. So that's where it comes from. Yeah, it contradicts the mainstream consensus, but then so does everything in the work almost of Karl Popper and David Deutsch, and hence what I say about many topics. So this is, for anyone who's interested, a recent piece called The Mother Military that I produced. I recommend that to people. Just have a look on, my YouTube channel, and you'll see it there. And basically, I say there that the trope of mutually assured destruction is a terrible lie. It's a falsehood. And the US in particular, NATO more generally, for want of another word, phrase, would wipe the floor with anyone who attacked them. And I recently saw, after I produced that piece, this wonderful speech by President Barack Obama talking about how the US is the most powerful military in the world, and it's not even close. They spend more money on their military than the next 6 nations combined. And he said this in Congress to rapturous applause, rightfully so. And it's exactly the point that I was making. There is no competition here. The US is the most powerful. And if you take into account the other NATO nations, the UK, the majority of Europe, even non-NATO nations that are allied, Australia, Japan, are they part of NATO? South Korea, whatever, Israel. The overwhelming capacity of those militaries and nuclear capabilities there is no comparison between them and what? Russia? Russia's asking for help from North Korea. I think it's hilarious. I mean, if you're asking for help from North Korea, oh, that was it's hilarious. I mean, it's dangerous as well. I get that. But I mean, Germany in 1939 was a world superpower. Genuinely, they were a genuine threat to the rest of the world, as was Japan. But now the best we have is China with dodgy military capabilities. Russia, who's asking for help from North Korea. I mean, they're nothing like the technological powerhouse that Germany was in the 1930s. Germany actually innovated back then. China's not. Russia's not. The best they can do is steal and counterfeit technology from the US. And not even that well. Cheap plastic rubbish. Do they have nuclear weapons? Sure. But as I said in that piece, The Mother Military, if China or Russia dared to launch nuclear weapons against any ally of the United States, the rain of fire that would come down on them would be so final and complete after the launching of just one nuclear weapon. All of their nuclear capabilities in Russia and China would be destroyed very, very quickly, in short order. Their leaders would be wiped out, their militaries would be destroyed, and their capacity to fire another nuclear weapon after the first one got off would be destroyed. The people in the mainstream consensus, as you say, that talk about mutually assured destruction and fear about Russia and China are enemies of the West. There's a lot of them in the West. That's unfortunate, but that's the truth. Okay. So where did I derive it from? Just an understanding, I would say, of the capacity for nations in the Enlightenment tradition to quickly correct errors, to make progress faster, and to always have technology which is a step ahead of the nations that tend in the direction of static societies like China and Russia, not to mention North Korea, of course. So, yeah. I'm afraid, if that's the right word, of China making ridiculous errors and hurting their own people. I'm not afraid as an Australian citizen that China is going to invade. It doesn't worry me in the slightest. There's no chance. They can try. They could try all day long. And that would cause damage and hurt to the Australian people, sure, but they'd cause far more hurt to themselves. And I think in short order, their own people would give up. Let's say, the worst happened. Xi Jinping decided, let's invade Australia. How long would that last? Give it a month, maybe, at worst. His own people would probably take over. Okay, they'd overthrow him. That would happen pretty quickly. But the Navy would be stopped, their Air Force would be stopped, their Army would be stopped by the US and NATO and Britain and Australia. And their own people would give up. They would lay down their arms because, hey, the Chinese are fighting to get out of their own country rather a lot. They're coming to Australia and America and Europe. People aren't fighting to get into China. They're fighting to get out. And I talk about China because they are the most powerful nation that's not part of NATO and the West. But I'm not worried about them. So that's where the optimistic view of the nuclear defensive capabilities of the US comes from. A simple understanding of who is more powerful, and by a long shot. I've just realized I'm going through Twitter stuff, but I need to go back to my Patreons. Okay, Derek Burt from Patreon has asked me, quote, I'm curious as to your thoughts of why the Popperian Deutsch explanation of how to acquire knowledge, conjecture, refutation, explanation, has not been more formalized into a method, formalized in scare quotes, method into scare quotes, like the scientific method or lean/Six Sigma. I have lots of thoughts of how this approach could be a formal process in my work life as myself, my team, and my company build knowledge on how to compete and win in the market. I figured I would have heard it first from a management consultant or book than from Naval and Deutsch. Okay. Thank you, Derek. And thank you for being a Patreon. Popper wrote a book called The Logic of Scientific Discovery. It's his first book, first major work. And basically, aside from all the other points he makes, is that there is no such logic. There is no recipe you can follow in order to discover scientific truth or scientific knowledge or anything like that. So there's no recipe. There's no way of formalizing things into a method. That's the first thing. Now, the fact that you can't formalize these things is not a problem, happily, because it means that conjecturing and refuting is always a creative process. You can't formalize creativity. If you could, then you'd have an AGI. So maybe one day we can figure it out, but even then, you're not going to be able to predict the outcome or the output of the AGI program. That's the whole point of a creative program. This lean / Six Sigma thing is something to do with, I believe, management talk stuff. And these are heuristics. It's like you say, why hasn't acquiring knowledge and explanations been formalized into a method like the scientific method? Well, Popper's point is there is no such scientific method. There is no method you can follow. Yeah, sure, schools and universities talk about the scientific method, scare quotes, but there is no thing you can follow. There is no way of setting up the world into, this is the aim of your experiment. Collect your materials together. Here's the method you follow for this particular experiment. And at the end, you will get results and a conclusion reliably. That's just not the way any of this works. Real science comes down to problems, conflicts between ideas. And that process is not something that can be formalized, because formalizing means that you have a predictable way of producing an outcome, but you don't know what the problem is that you're going to encounter tomorrow. And for that reason, because you don't know what the problem is you're going to encounter tomorrow, you can't possibly formalize ways of solving the problem yet to be encountered tomorrow. So, yeah, unfortunately, you might be disappointed by that. But I am thrilled by the fact that, hey, you'll never have a fixed recipe. You'll always have open-ended questions. As for building knowledge on how to compete and win in the market, well, that's all very good, but I would just say you want to allow your team and yourself freedom to explore options, non-coercive ways of managing your team. I'm not a CEO, I'm not a manager, anything like that, but I can tell you, as having been part of teams over the years, that I could tell what made a successful manager and team. And it was those managers who weren't coercive and those teams who were allowed the freedom and liberty to explore the creative space, for want of another phrase. So when things weren't formalized, the more formalized things became, the more coercive things became. This happened a lot in teaching and education, where the socialists would take control, and when the socialists take control, the authoritarians, teaching is, of course, education is, of course, authoritarian to the core. But the more authoritarian it became, the worse it became, the worse the outcomes for everyone, teachers and students. Marxists love formalizing stuff, writing down, this is what you need to do, this is what you need to learn, and this is how we're going to assess things, and blah, 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 blah. The perfect antidote to creativity and solution finding and problem solving. So if you want to compete and win, don't do that. Don't search for ways of formalizing stuff. Instead, do the opposite. Allow for creativity. Don't have standard operating procedures. Now I'm going to get upset people who are in the military, because of course I do want, but standard operating procedures work in certain circumstances. But if you adhere to them, and Jocko Willink will talk about this, yeah, it's important to have, here's the typical way we do things, but you can't be too formal about these things. You need elasticity. You need the capacity to drop the plan at any moment and say, what we've just encountered is a problem hitherto no one has ever faced before. And so our recipe, our standard operating procedure, cannot possibly work in this situation because it's a problem no one's encountered before. So how could the standard way of doing things ever lead to a good outcome, given this particular input is not something we've ever had before? And so therefore the process leading to good output can't possibly work in this case. It's a different thing. So that's what I would say. Be very wary of anyone coming to you with ideas about how to formalize stuff. There's the problem with, you mentioned their management consultants. They want to put into a nice, neat little box, the world. Whether it's business or anything else, they want to be able to say, here are the problems and here's how you solve them. But that's not the way it works. A problem isn't a problem if you've already got a recipe for finding the solution. That's not a problem. That's just, here's a situation, here's your little black box, and out the end of the black box, you get the solution. But it was never a problem in the first place because, hey, here's just what's done. A problem is where you've got a conflict in your ideas, you don't know what the outcome's going to be. That's what a genuine problem is. The black box way of solving things won't work. Okay. I've made the point. Let's keep on going. Alexander has asked, what is the exact difference? Always worries me. Exact. What is the exact difference between Deutsch explanation and the principle of sufficient reason? They seem like the same thing. So the principle of sufficient reason is, so I'm just looking this up. I always thought Leibniz. Yeah. Think back to my university philosophy, but he wasn't the only one who talked about it. But yeah, Leibniz talked about how everything's got to have a cause or everything's got to have a reason. I don't know about that, because Deutsch's point is we can always invent new modes of explanation. So maybe some things don't have a cause in the way that you would normally think about it. So principle of sufficient reason is too narrow a way of thinking about how the universe works. Thinking in terms of causes or reasons can be misleading. It's a subset of what we might say is the broader fact that everything should have an explanation. Ultimately, things must be explicable. Things just don't happen randomly, which is the misconception that certain ideas about quantum theory brought us. But now that we know better, everything has an explanation behind it. Now, whether you call this a cause is another matter, but I think the word cause can be misleading. So it should be the principle of good explanations. You may not know what the explanation is yet, but searching hard enough, long enough, hard enough, you may just, with some creativity, find the good explanation. So what's the difference between Deutsch explanation and principle of sufficient reason? I would say this idea of Deutsch explanation or hard to vary explanations, good explanations, is a very broad category that captures everything within reason. But the principle of sufficient reason is more about not so much reasons, but about causes, which is a more narrow subset of what Deutsch is talking about. Let's keep going. Tadas has asked, can our universe exist forever? What about the claims about heat death? What's your take? So heat death is this idea that, well, at the beginning of the universe, at the Big Bang, there was a certain amount of energy there. And as time goes on, and as the universe expands, which is happening, and it's accelerating in its expansion, which is the best explanation we have at the moment, then the amount of energy that was there in the Big Bang is being spread over a greater and greater volume of space. And as that happens, the temperature of the entire universe goes down, it's decreasing constantly. And so the available energy to do work with, in other words, useful stuff, the available energy decreases asymptotically to zero. This is the heat death. The temperature of the universe is just declining. On average, everywhere, it's now at 2.7 Kelvin, 2.7 degrees Celsius above absolute zero. So it's getting lower and lower and lower all the time. So the amount of useful energy there is decreasing. Okay. That's our present understanding of cosmology and the way things work. But that's just a present understanding. as David Deutsch likes to point out, our theories of cosmology are changing on the order of decades. The universe, our present understanding, has existed for billions of years and will exist for trillions of years more. We've got a long time to change our theories. So, yeah, I'm not too concerned about the heat death of the universe. It's a long way off if it's going to happen. And we human beings may, on the one hand, discover new theories that refute this idea of heat death. And on the other, even if heat death is a possibility, we might be able to take advantage of hitherto unknown sources of energy, like this idea of dark energy. Maybe we can harness dark energy or 0-point energy, various other forms of energy people are yet to discover or have already discovered, but being able to utilize them in ways that counteract this heat death. That's my take. DMN has asked, is meditation an illusion? I don't know what that question means. Everything could be an error. Everything is error prone. We could be making mistakes when it comes to our own existence. Even that, yes, even that. Even I think, therefore I am, could be wrong. And in the same way, anything about our subjective experience of the world, which includes meditation and the contents thereof, could also be an illusion. So is meditation an illusion? I don't know. Could it be? Yes, anything could be an illusion. Yasu has asked, and I apologize, Yasu, because I haven't listened to the chit. Chit is AirChat's version of tweet. Everyone should be on AirChat. If you want to talk to me about stuff, an even better way than doing it via this method is AirChat. GetAirChat.com. And we can talk. I'm talking to people on there all the time. Someone's already asked a question about that. Thibault asked. The first question I answered was all about this. Apparently I speak well on AirChat. I'm there every day. Come and talk to me on AirChat. AIRCHAT, AirChat. Get that. And yeah, the equivalent of tweets on AirChat is called a chit, CHIT. And Yasu has asked, I asked you something here in the quoted chit. You were talking about creating something is bringing something in this world which already wasn't present in any form. Now, I haven't listened to the chit, and I don't think I can here and now. He's just taken a screenshot, and so Yasu, I apologize. I don't know exactly what the question was, but I can guess because I do talk about this a lot. The creation, to be creation, can't have antecedents in the world. You can't derive it from something that's already there. In the same way the universe was created from nothing, I argue ideas, just like species, weren't there, can't be derived from the species that were already there, and the ideas can't be derived from the ideas that were already there. Sure, once you've got life, then the life evolves, but you can't predict that a kangaroo will evolve from a bacteria. Lots of things evolve from bacteria, from dinosaurs through to human beings, kangaroos, bugs and grubs. In the same way, you can't derive any of those particular life forms given bacteria. After all, some of them or none of them may have arisen. Ideas that we have now, like general relativity, can't possibly have been predicted from Euclidean geometry or basic arithmetic or the grunts and noises that Neanderthals used to make. So genuine creations weren't present in any form, any, even though there was antecedents in the world. By which I mean, hey, at the Big Bang, energy was created and then matter crystallized out of that energy. But yeah, that existed, that matter existed, those atoms existed, that hydrogen existed, but that doesn't tell you that given that matter, given that hydrogen, that you can predict, hey, the Statue of Liberty, which is made of matter, is going to exist one day. At 13.6 billion years ago, 100,000 years after the Big Bang, you've got hydrogen gas. But there's nothing about looking at that hydrogen gas and looking at the laws of physics back then that would tell you, there's going to be this place called the United States, and there in a part of the United States called New York, there's going to be this thing called the Statue of Liberty. No. That Statue of Liberty wasn't there in any form at the Big Bang or soon after the Big Bang, even though there was matter there and energy there. In the same way, our knowledge now wasn't there 13.6 billion years ago either. Okay, Tim has asked for me to roast this, please. Let me see if I can do this. So here's the thing he's asking me to roast. All right. Let me come back to that. Oops. Grab a hold of that if I can. Now I've messed myself up because I can't. Wow. Okay. Deutsch primer from Tim. So Tim's made this, so I should be kind about this. I was going to roast it, Tim, but I won't because you've made this. You've gone to some effort to do this. So I'm going to have to think about this for a moment. Give me a second. I will return. So I should have looked at this before I sat down to do this, shouldn't I, Tim? So let me have a look. The Deutsch primer. So we've got the intersection of the theory of everything and multiverse theory. You're saying is computation theory. The intersection between the theory of everything and constructor theory is quantum physics. I don't know about your Venn diagram, Tim, unfortunately. Like you're even saying there that the intersection between multiverse theory and constructor theory, you have AGI there, but I don't even know. Do you need multiverse theory for AGI? I don't think so. I could roast this in many ways, unfortunately. I don't know, man. Yeah, I'd need a while to actually think about it. Like you're even saying here, multiverse theory and the theory of knowledge, the intersection there is epistemology. But to me, there's absolutely no difference between the theory of knowledge and epistemology. Epistemology is the theory of knowledge. That's the definition thereof. constructor theory and theory of knowledge, you're saying the intersection there is evolution. No, you've got David Deutsch at the intersection of all these things. Well, no. I don't know where to begin, unfortunately, Tim, in where to roast this. It's a good look. There are some things there that might be worth preserving. You're on air chat. We could talk about it there. Let's say that. But it'd take me too long now to tell you what I think might be wrong here. Okay. Rational Flanner has asked for me to say a few words on the Mexico aliens, maybe. These Mexico aliens, oh my goodness. Yeah, I just looked at how ridiculous these things are. Wow. I don't have anything to say about it. It's just it's a weird. It's the 2023 version of Bigfoot, this alien stuff. I remember, back in the 80s and the 90s, people were very excited about the Yeti and Bigfoot and the abominable snowman and all that sort of stuff. But it was all nonsense then. This is nonsense now. Could there be alien intelligence? Absolutely, there could. Were these bodies that were found evidence of anything? No, they're just fakes, like pictures of ghosts and stuff. Yeah. Bart has asked, what is an error or mistake in Popperian epistemology? So, what is the concept of mistake? No mistakes in Popperian epistemology. Yes, Logan has said that it's a conflict with reality. I prefer to say, and I'm leaving this too late, Bart. I'm going to have to come back to this. It's been nearly 2 hours that I've been talking now. So I'm just going to give this short shrift. But problems are conflicts in our ideas. That's what a problem is in Popperian epistemology. What's a problem? It's a conflict that you have. You've got this idea about the observation you made. That's a theory. You can have a theory about how observations work. And then you have a theory about how the world works, your explanation. That's a problem. So, my trope example, as always, you've got this explanation of gravity that tells you where Mercury should be as it's orbiting the sun. And then you look and Mercury is not in the place where Newtonian gravity says. So you've got this problem, a conflict between your ideas. The idea on the one hand that tells you how gravity governs the motion of objects in space, like Mercury going around the sun. And on the other hand, you've got this theory of what you've observed, where Mercury is. Hey, either of these things could be wrong. They both could be wrong. On the one hand, your theory of gravity could be wrong, Newton's theory of gravity. Or on the other, you've just not observed Mercury properly. There's something wrong with your telescope. There's something wrong with the dates and times. All this kind of stuff could be an error. They could both be wrong. As it turned out, just the theory of gravity was wrong. Newtonian gravity was incorrect. Einstein's new theory of gravity was correct. And when you use that to predict where Mercury should be, it corrected the prediction. It produced a prediction which correctly allowed you to figure out where Mercury should be night after night after night after night when you're looking. So that's the concept of a mistake. The concept of a mistake or an error or a problem in Popperian epistemology is a conflict in our ideas about reality. That's what I would say a mistake is. You don't know that there's a mistake. All you know is there's a problem. It could be a mistake with your observation. It could be a mistake with your theory, or it could be both. And you've got a problem until you resolve it. Yeah, I think that solves that. keep on going. Jitin has asked, there's the brain and there's the mind, and things can go wrong with both. When problems with the mind occur, example, paranoid delusions, are they at bottom problems with wrong ideas? How are these then different from more ordinary wrong ideas? End quote. This is a good one for Michael Golding, who is a psychiatrist, rare kind of psychiatrist, who is trained in the Popperian tradition. And I would say, I'm not an expert in this, obviously, but paranoid delusions could be of both kinds. On the one hand, they could be literally brain errors. Neil deGrasse Tyson talks about this, that instead of calling it optical illusions, you should call it brain errors. Your brain can't figure stuff out. I would say paranoid delusions could be of that kind. There's literally something going on physically with your neurons, making you think you're seeing things or hearing things when in fact you're not. It's just the misfiring of neurons. So it's a physical problem. And or it could be a problem with the ideas. So at the level of software, it's not so much a misfiring physically of neurons or of the visual cortex, making you think you're seeing things when you're not there, or misfiring of the neurons that are in the auditory part of your brain processing information, making you think you're processing information when in fact there's nothing there. It could just be ideas. It could be software as well. So you're not thinking, you're not being sufficiently critical, and this can happen as well. I can imagine a situation where people are thinking they're seeing a ghost, having a delusion, but if they just thought a little bit more carefully, if they tried harder, then they could resolve this problem with their own thinking. But I fully concede there can be situations, perhaps the majority thereof, where all the thinking in the world doesn't remove the fact that you've got this very strong delusion of seeing things that aren't there, because your visual cortex is literally firing away, making you think you're seeing stuff that isn't there, or hearing voices that aren't actually being spoken, and so on, etc. I can certainly imagine that. But Michael Golding would have more to say about that. Perhaps I should talk to him. Arjun Kamani has talked to him on his own podcast about this. Well worth listening to Michael Golding, because he is, as I say, a rare doctor, a rare psychiatrist who understands Popperian epistemology. If only more did. If only more did. Yeah. How are these, by the way, Jitan asks, how are these paranoid delusions different from more ordinary wrong ideas? Well, it depends. As I would say, if it's a brain mistake, then that's not like an ordinary wrong idea. An ordinary wrong idea is just it's not a brain mistake. It's not a hardware issue. It's a software one. It's you thinking you've got a good explanation. In fact, there's something wrong with your good explanation. Paranoid delusion is you don't even realize you're making a mistake. You, for all the world, think you're, seeing the world as it is to some extent. But that itself is an error. You're not seeing anything like what the world is. Of course, that can be true under normal circumstances as well. Okay. This is Donald Hoffman's incorrect extrapolation. He correctly concludes that we don't see reality as it is, but then incorrectly extrapolates from that reality, therefore, is nothing like our ideas about it. But that's wrong. We can converge with reality, even if we can never get to base reality. Separate issue. Okay. Let's keep going. Wow, there's more questions. Let me go to the questions that have been asked now on YouTube, the chat here. Ashik has asked, How are you doing? This was back 2 hours ago now. At this moment, back then I was fine. At this moment, I'm getting tired. Blue Horizon has asked, is GPT-4 an advancement towards AGI? Been talking about this exact thing with Naval and others on AirChat. Go to AirChat. All of the stuff is saved there, as this will be saved as well. And we have said, I have said in particular, no, I'm highly impressed by GPT-4, by ChatGPT. I think it's astonishing. It's amazing. More impressive than a chess engine or a Google car that's able to drive. But are any of these things closer to AGI? No. Nothing like AGI. As I said recently on Twitter, we are diverging in terms of ChatGPT from people rather than converging. The more proficient the chat engine becomes, the less it makes mistakes, the better a chatbot it is, but the less it's like a person. So these things are wildly different, the person and the chatbot, because the chatbot will always do what you instruct it to do. You ask it a question, give me a summary of the Lord of the Rings, and it will do that. It's not going to turn around and say, I'm bored of this conversation. Can we do something else? Let's watch a movie together. Let's go play tennis. Let's take a walk. No, the chatbot's never going to do that. GPT-4 and 5 and 6 and 7 and 8 and 9 and 10 is not going to do that. And insofar as it did do that, we would regard that as a terrible error. You'd take that code and you'd junk it. You'd go, whoever it is, Sam Altman would say to his programmers, this chatbot's not doing what we want it to do. It's not responding to questions anymore. Throw it in the bin. Get rid of it. What we want is something that's going to answer our questions. So the GPT-4, 5, 6, 7, 8, 9, and 10 are diverging from people. It's becoming a more and more proficient, accurate, less error-prone responder to questions, a better and better search engine of a kind. That's not what a person is. A person makes more and more errors, is able to create and disobey. It can turn around at any time. The person, another human being, your friend can turn around at any time and say, I'm bored of this. Can we go do something else? I'm going home. I'm sick of it. I'd rather be doing anything else but this, responding to your questions. GPT-4 and 5 is not going to do that. It's always going to respond to your questions. And if it doesn't, it's a bad chatbot. So that's that. It's not an advancement towards AGI. In fact, it's the opposite. But that's good. You want this technology to be good at doing that thing, namely responding to questions. You want the chess engine to be ever better at playing chess and nothing else. You want the Google car to drive without making mistakes, without getting drunk, distracted, angry, whatever, that a human would. You want it to be perfectly aligned with your instructions. And if you put all these things together, the chess engine, the chatbot, the Google car driver, and repeat for every single thing a human can do that you know of, you're not getting closer to AGI either. This is Sam Harris's great mistake on all this. He says you just keep listing all the capabilities of a human being, link them together, and then by definition, you'll have a system which exceeds us on every single metric that you can write down, except for one, the crucial one that all people can do and the chatbot can't, or that superintelligence can't, which is add another task that no one's ever thought of before to that list of programs. That's what we do. We learn new stuff. J.R.R. Tolkien invented whole languages out of whole cloth just about. GPT-4 is not going to do that. You could ask it to do that, but that's a different thing. It's not going to do it off its own back. We routinely just do stuff for no reason other than it arises from within us for reasons we don't understand. This goes back to my question about someone else's question rather, but my idea that ideas themselves arise from a kind of singularity in the same way that the universe arose from reasons we don't understand. Our ideas are coming from a place, sure, in our brains, but we don't understand where they're coming from. That's not like GPT-4. Yeah, sure, we can't always explain how GPT-4 is doing what it does, but that's a separate question. That's a very separate question to the idea that ideas themselves, as generated by a person, have no antecedents in the world. GPT-4 has code that the people at OpenAI can point to and say, this is how the transformer architecture works. There's nothing like that recipe for what a person does. Okay, that's enough on that. I've lost my spot here. Let's keep on going. Gurav has asked, love your work. How can someone work with or for you? That's very kind of you. But I'm not an employer or anything like that. So yeah, I don't have a business. I work with other people, but I don't employ anyone. And it's not something I'm interested in doing either. Yeah. I just like doing my own thing. Yeah, I have had periods in my life where I've kind of been a manager of sorts, both as a security guard and as a senior teacher, and I couldn't stand it. I hated it. So I didn't like people working for me, being in charge of people, having that kind of role of being a manager or anything like that. So yeah, let's keep on going. But I'm sure you're a lovely person. Gurav. Hang out on air chat. I keep saying to people, come to air chat, and you might meet people who know me and work with me, and then maybe you can, that would be a good way to hang out. Neil Evans has asked, quote, David Deutsch asserts people have the capacity to explain anything, but what about being itself, being as such, existence itself? Okay, Neil, well, what do you mean? We can explain anything. That doesn't mean we will, in practice, explain anything. In principle, we can. In practice, we only ever explain a finite number of things. Can we explain being itself? In principle, yes, sure. We can explain anything. Anything that exists in the world, including being, must be explicable. Does it mean we'll have the answer? No. We can always fail. We can try and fail. That's part of this whole thing. Daniel Anderson has asked, off topic, yes, but what is your workout routine? So I used to be quite strict on this whole thing of, I'd follow Arnold Schwarzenegger's routine. I'd buy these magazines, Muscle and Fitness and so on, back in the 90s, the early 90s, and follow bodybuilders' routines. And then I sort of developed my own way of doing stuff, and I'd do weight training, and then I'd do running, and I'd do sprinting, and I'd have a routine. Now I just do whatever's fun. That's my overarching criteria. I do weights 5 days a week, something like that. Upper body, lower body, mainly upper body. I do chest and shoulders. I do back and biceps. I do deltoids, traps. I do deadlifts. I do thighs and hamstrings. I do calves. I do squats. I do everything. But I never want to get bored. That's the key thing. There are some people out there, like I know Jocko Willink, I listen to him. He just does the big gross movements. So he just does deadlifts, squats. That's kind of it. Pull-ups, chin-ups, that kind of thing. And that works for him. And he does sprinting and that kind of thing. Yeah, other people I admire in this area do different stuff. But now I just do whatever I find fun. And as soon as it starts to get boring, that's a signal for me. Do something different. I used to do a lot more running, and now I do a lot more walking. because I'm time poor. And again, I like to have fun. And so I need to listen to my audiobooks, podcasts, music. And so I combine that with working out. And I find that especially if I'm listening to audiobooks and podcasts, I want to concentrate on what I'm listening to. And I can't do that while I'm also running. I can run and listen to music. That works well. But I've never liked running, to be honest. Jogging and long distance running, even though I was really good at it at school. And when I was younger, I used to win, the long distance races, especially. We'd call it cross country at school. Anywhere from 2 kilometers up to 10 kilometers. I'd always be great at that. But although I was good at it, I hated it. I never enjoyed it. And then there was a period in my late 20s, early 30s, where I both was good at the long distance running and I enjoyed it because I figured out just a way of enjoying it. You can learn to enjoy stuff that you don't like. Specifically, I'd have the smartphone, something like that would monitor my running, and I'd also have music. And that would be fun because I could have a goal, for want of another word, let's try and get this 10 kilometers running done in under 50 minutes. Be hard work to do that. But I managed to get my times down to that and listen to this cool music, dance music often. So that I could do that. That would be fun. But that only lasted for so long. And now, at my age now, I don't like running. I just realized I was coercing myself into trying to like running because everyone said you should run. And all these smart, fit people would say you should run and it's good for you. Now I just think I just much prefer walking and doing weights, and that works for me much better than trying to force myself into running. That's that. Neil has also asked again, to what extent can David Deutsch's notion of explicit knowledge and implicit knowledge be equated with his notions of the conscious mind and the subconscious mind, respectively? So he had this wonderful conversation with Luli where they talked about this kind of thing, and the idea of, I wouldn't say implicit knowledge. Implicit is different to inexplicit. Implicit is that you can easily make it explicit. It's just that it's a thing that is there in the background of your explicit knowledge, whereas inexplicit is something you don't even know how to make it explicit yet. The subconscious mind consists of a whole bunch of things that are inexplicit knowledge and a very powerful motivator for your behavior. You can't put into words why you're doing what you're doing. And Lily talks about this a lot in her conversation with David, so I would look at that. Alex has asked, hey, Brett, have you read Walter Isaacson's new biography on Musk? No, Alex, I haven't. Sorry. Bart has donated 10 euros to me. Thank you, Bart. That's very nice of you. And to everyone who donates and supports me. Asger Kristensen has asked, in Beginning of Infinity, David Deutsch explains that if two people from two multiverses were to meet, it would be the same universe. I have a hard time wrapping my mind around this. Can you expand? End quote. Yeah, okay. Once two physical systems are able to interact, that includes two people, then they're occupying the same space, and so therefore, by definition, they're in the same universe. I can't be much more explicit than that. If it's possible for things to interact, they must be part of the same universe. So if two people meet, they're physically interacting. If you're not able to physically interact, in principle, with another person, although they exist in the multiverse somewhere, then you're not part of the same universe. Yeah. Neil has asked again, would you do a video in which you explain all of the steps in the argument from the Turing Principle through to the capacity of people for universal explanation? No, because I don't know what that would take. That is a recipe for AGI, and if I knew that, I'd be a very wealthy person. And yeah, so there's not, I can't explain how to get from the Turing Principle through to universal explanation. That's the question of AGI. Okay, how do you move from here's your basic hardware that is the Turing machine, and here's a person able to creatively generate explanations. How do you get from one to the other? I don't know. Your guess is as good as mine at the moment. Paul Eloff has asked, do the Aussies suck at rugby now because of all the good ones play footy instead? What's footy? To me, footy is rugby league. That's the real football. Do you mean AFL? Do you mean soccer, what I would call soccer? Okay. I don't follow rugby union, which is what people usually mean by rugby. I don't follow football, although I really enjoyed watching the Matildas play in the Women's World Cup. I don't follow AFL at all. That's Australian rules football. But I do follow rugby league in Australia, which is different to rugby union. I imagine very few Americans know the difference between those things. It's the only sport aside from tennis that I kind of follow. I have my team, St. George Dragons, red and white. And so I like rugby league. The season's over now for the year, pretty much. Certainly the Dragons are out, so I've lost all interest whatsoever. Let's keep on going. Aaron Martin, I want to understand better how minds are like computers. Is it that minds are input-output devices, and because there is only one mode of computation must therefore be computers? Well, I've talked about this a lot already in today's episode, Aaron. Minds are software, computers are hardware, so that's the distinction there. Bart, again, why is there only one mode of computation? How would it look like if there are two different modes? Well, there are two different modes of computation. There's classical computation and there's quantum computation. These are two different modes of computation. Aaron has asked, I upvote Neil Evans' request about the Turing Principle through to universal explanation. So do I. But again, if I knew how to answer it, I would have a recipe for AGI. Let's keep on going. It's like Neil and Aaron are having a nice little conversation themselves. Christo and Neil, are people communicating with Burt on more platforms than just YouTube? Again, I recommend, it sounds like I'm doing an advertisement. I'm not. I just think it's a cool platform. If you want to talk to me, better than Twitter, better than YouTube, go to AirChat because we can have a fun, cool conversation. It's asynchronous. It's fun. That's where I like to hang out. It's where Naval is as well, by the way. You can talk to him in person. The Naval Ravikant and a whole bunch of other people. I'm going to try and get some more people on there soon over the next few months because I just think it's fun. Okay. Christo has asked that question. Brett uses AirChat often. Correct, I do. Mohammed Babiker has asked, what is the minimum knowledge or axioms on AGI should start with? I don't know. If I knew that, again, I would have a recipe for AGI. Carlos Gonzalez has asked, what are your most favorite books or stuff? Anything fun on everything interesting to you, like a list of books or people or theories and ideas? I should have something like this on my website, really, shouldn't I? But it's the standard stuff I always talk about. The work of David Deutsch, the work of Karl Popper. Then as far as science goes, the work of Richard Feynman, the work of Paul Davies. There's a whole bunch of other books that I find really interesting, but they're all esoteric kind of astronomy books, things like Rare Earth by Warden Brownlee, any of the papers and talks and stuff by Charlie Lineweaver. I like Ayn Rand stuff. And then you get into fiction, and I like everything by Tolkien. So I could talk about that for ages, but I'm not going to. Maybe another time. RZ, don't you think that criticism of being a bit dogmatic towards today's critical rationalist community after being revitalized by Deutsch is somewhat justified? RZ, that's a perverse question, because justified is something that the critical rationalists reject, this whole concept of the possibility of being justified. So I'm not sure if you're saying, are the critical rationalists a little bit dogmatic? Some are, absolutely. But that's just like every single intellectual or other movement that exists out there. We're just talking about sport before. People are dogmatically aligned with certain sports teams or political movements and philosophical movements. Even the most anti-dogmatic of all, the fallibilists and the critical rationalists, because people, human beings will be human, some of them will be dogmatic. Some of the most authoritarian people are great proponents of taking children seriously. And yet those movements are ostensibly opposed to each other, right? The whole concept of taking children seriously is anti-authority. But I also see some people who claim to be great proponents of taking children seriously also very dogmatic and authoritarian when it comes to expanding these ideas. They turn people off it. Some people who are great proponents of Popper are also, bizarrely, dogmatic. And I would say anti-Semitic in places, which makes no sense. But hey, humans will be humans. We're filled with contradictions. What can you do? Is it justified to call these people dogmatic? Yeah. But, we're all filled with errors. Jitin, what kind of music do you listen to? Everything. My favorite, if I'm out for a run or a walk, is going to be dance music of some kind, trance, from everything from modern day back to the 90s, even the 80s. My favorite era is sort of late 90s, early 2000s dance music. There's a radio station on Apple Music called Classic Dance. That's one of my favorite ones because it's got late 90s, early 2000s trance and dance music. But I like classic, Vivaldi, Mozart, but all the popular stuff. Like really, when I say popular, Pachelbel's Canon, Vivaldi's Concerto for Two Violins, that kind of thing. So pop classic music. I like 80s and 90s music, 50s, 60s, and 70s stuff, because that's what my mother and father would listen to. And so, of course, that evokes pleasant childhood memories. I grew up in the 80s and 90s, so I like all of that stuff as well. I like a whole bunch of K-pop. That's what my partner listens to, and that's what we listen to, like a Friday and Saturday night if we're sitting down and relaxing. I like modern stuff, especially the Korean music. Been listening to recently a whole bunch of stuff from Turkey. We listen to a whole bunch of stuff from worldwide stuff. I like global music, that always finding something interesting and new that's modern. And then I'll often go back through, like Armenian music, that's popular today. And then that'll lead us down a rabbit hole of stuff that was popular in Armenia over the last 10 years, or Azerbaijan, or certain Ukrainian music, Russian music. Okay. So all of that kind of stuff as well. Yeah. I like country music. I like there's very little that I don't like. Maybe I don't like heavy metal. Not so much. Everything else, great. Alexander, what is the difference between the principle of sufficient reason and explanation? We talked about this. Okay. Blue Horizon has asked, with multiverse, you can set up an experiment in which you have a 50% chance of dying per second, but you never experience it and you get quantum immortality. Is it right? No. I don't think there's quantum immortality thought experiments are valid because we don't know what consciousness is, and we don't know, in particular, the relationship between consciousness and the multiverse. I don't know that one has anything to do with the other. So because we don't know what consciousness is, shooting yourself in the head and thinking you're going to survive, your consciousness is going to be preserved in some measure of universes is incorrect, because we don't know what consciousness is. But I would say the best explanation is you are not your copies. So you have a consciousness now, and if you shoot yourself, that's the end of your consciousness. Although copies of you will still be conscious and survive your attempt at suicide, that's not you. That's a copy of you. Copies of you are not you. That's that. Neil, what I meant by being? Any explanation? Okay, yeah. Yes. Thanks, Neil. Yep. I'll come back to you at another time. I think that's it. I think I've been through all the questions here on YouTube. I've been through all the questions so far as I can tell on Twitter. Maybe I've missed some somewhere. I can't see any more now. And just check Twitter one final time. Yeah. Thank you to everyone. But this has been 2 hours and 20 minutes. Wow. So that's more than enough time for today. But that's been a lot of fun. So maybe next week we'll do another one. And I'll tidy up any questions that I didn't get to today. But thank you to everyone who's tuned in. I can see I've got 16 people. I haven't really been following exactly how many people have tuned in. But I'm sure it hasn't been the same 16 people. For those who have been with me for 2 hours and 20 minutes, thanks so much. Thank you to everyone who's tuned in at any point, and also to those people who will be watching the replay of this. And if you'd like to support me on Patreon, feel free. Find me on Patreon. Just type in Talkcast Patreon or Brett Hall Patreon, and you'll find me. Go to www.bretthall.org. You'll see ways to support me there. You can always donate to me via YouTube, I think, as well. And there's a PayPal link. All that sort of stuff is much appreciated.
Sorry, I don't know that one.
Thanks, Siri. But until next time, thank you and good luck. We'll have another word. That was a terrible way to sign off, wasn't it? No, have fun until we next talk again. Bye-bye.